Hello. So welcome to this little video on graphing rational functions, part A, or the first part. Let me find a little handy pen here. And we're going to be focusing on three things. We're going to focus on completing a table of values. We're going to draw the function on the coordinate plane, and then we're going to write the domain and range of the function using set notation. Okay, let's begin. Well, here's the function here. H of x equals 9 divided by x minus 7. So what we have to do is we have to complete this table here. And so basically it's saying it's given us the values of x. It says, well, find h of x when x equals negative 9. Find h of x when x equals negative 6. Find h of x when x equals negative 3. Let's just take a look at that. I'm not going to do all these. This is a lot. I think I'll do 3 or 4 of them, and then you'll see the pattern. Once you see the pattern, you'll know how to do it. Right, so we need to find h of x equals 9 over x minus 7. So we need to find h of negative 9. Basically, what is h of x when x is negative 9? So what we do is say, well, x is negative 9. So we'll say we just replace x with negative 9. 9 divided by negative 9 over minus 7. Well, 9 over negative 9, that's just negative 1. Minus 7 equals negative 8. Voila! Look at that. We've got one of these boxes filled in right there. We're making our way through. So now we'll do that for negative 6. We'll say, well, what's h of negative 6? Well, we just replace x with negative 6. We'll say 9 divided by negative 6 minus 7. Well, 9 divided by negative 6 is, well, we could just do some reducing as 3 halves. Negative 3 halves minus 7. Well, negative 3 halves is just negative 1 and 1/2, right? So that is going to be, so negative 1 and 1/2 and negative 7 is negative 8 and a half. We could put that in here. Negative 8 and a half. Well, what about when we, for negative 3? So h of negative 3 is equal to 9 divided by negative 3 minus 7. Well, 9 divided by negative 3, that's just negative 3. Negative 3 and a negative 7 is negative 10. Oops, that's a negative 10. Oh. I lost my pen. Sometimes I lose the pen. It's really small for me. Now, negative 1. I'm just going to give it to you. That's negative 16, right? Okay. Now let's look at this puppy right here. Whoa, let's look at what happens with this right here. Okay, so we're going to do h of 0. What do I want to do? I will do it right here. H of 0. What happens when x is equal to 0? We get 9 over 0 minus 7. Oh my, this says 9 divided by 0. 9 divided, well, that's a division sign. I don't have an eraser on here. Divided by 0. What does that equal? Can you do anything with that? Well, I don't know. Let's just explore it a different way. Let's say 9 divided by 0. So basically, we know how to do division this way. So we're saying we need to put something in this box right here, right? And we need to say something in this box times 0 is going to give us 9. Is it possible to put something in this box? Is it possible to find a number, any number to put in this box that we multiply by 0 to give us 9? No, we cannot. That means it's undefined, right? Whenever we have a 0 in the denominator, it's going to be undefined. So we know that 9 divided by 0 is undefined. Well, undefined minus 7. Well, minus 7 isn't going to help us at all. And once we have undefined, the game is over. It's done. No matter what term or where we have it, it is over. Done with, kaput. It's out of here. Goodbye. So when x is 0, h of x is undefined. Undefined. Oh, I love my sloppy handwriting. Not really. I wish it was better. So I'm not going to fill in 1, 3, 6. You guys can do that on your own. Well, I'm going to show you. So here's the table. Here's what it looks like when we have, the table's all filled in. When x equals 1, h of x equals 2, you know, so on and so forth. So it says, okay, first it says complete the table of values. So we did that, right? And then it says draw the function on the coordinate plane. Okay, so what I did is I kind of changed things around a little bit. You know what we said, this top row is saying when x equals, I put that equal sign there to help you understand, right, that we're talking about when x equals -9, h of x, or another way to think about it is y is equal to -8. Because now we're being asked to put it on the coordinate plane. On the coordinate plane, we're used to x and y. So let's write it this way as a pair of coordinates, okay? If you write it this way, sometimes it might be helpful, right? When x equals, this is x, and this is h of x. Or, you know, in other words, we might think about it as y. And when x equals -6, h of x equals -8.5, right? When x equals -3, sorry, I don't have an eraser. When x equals -3, h of x equals -10. We put it in this system, it's a little bit easier to understand. -1, -16, and of course, we don't have anything for 0. When x is 0, it's undefined, and so on and so forth, right? You can do the rest of that. You can put the rest of them. In fact, you probably don't even have to, but when you do that, if you get stuck with this concept and you're not sure how to handle this table, you can just write them this way, and you're like, oh my gosh, I've seen these before, I know how to do this. Now, let's take a look. Well, we plot the points. Once we plot the points, right, here they are here. Here is -9, right, and -8. Here is -6 and -8.5. Here is -1 and -16. So we plotted the points, and then right, and then here's 1 and then 2, and then what's this? This is 9 and -6. So I plotted all the points, and then once you plot all the points, you can draw your line. But one of the things that we're seeing here, here's this line here, y equals -7. Look at that. The graph never touches that line. And think about it. It can't ever touch that line because in order for y to have some value of x that will give us h of x equals -7, that's impossible because we would have to have this term here equal to 0. Because it would have to be 0 minus 7, right? And that's the only possible way we could get -7. But there's no way to get this term to equal to 0. There's no value of x that we can put in here to make this term 0. Because as soon as we put 0 in here, remember it's a denominator, it's going to be undefined. We can't do that. So look at that. So there's no possible way that this function is going to ever touch the line y equals -7. So let's take a look here, and the last part is, so we drew the graph, now we have to do the domain and range. Well, the domain is going to be all possible values of x. Well, we've already said that x can't equal 0, but if we take a look along the x-axis, so let's just take a look along this x-axis right here, and we follow it out. If we follow this x-axis, for every value, except for 0, right, except for when x equals 0, there's a corresponding value to y. So look at that. There's a corresponding. So that means it's going to be equal. That means every real number is going to work. And if we go to the negative side, right, we have a corresponding value for every value of x going in the negative direction. We have a corresponding value of y. That means it's got to be all real numbers. So it's going to be x such that x is an element of all real numbers, right? But x cannot be equal to 0. We already said that. We said that my brackets are falling apart here, right? There's no way it could be equal to 0, and we can see that on the graph. It'll never touch 0. It'll never touch x equals 0. Okay, so now let's take a look at the range. Well, what we said about the range are the possible values of y. Well, if we look at the graph, right? If we look at this graph, it's coming down, coming down, coming down, coming down, coming down, coming down. Whoa, it's going down. Oh my gosh, does it ever touch y equals -7? No, it can't ever touch y equals -7 because we can never get 0 in this term. We can never get this term to be equal to 0. So then the range is going to be equal to, or it's going to be h of x such that h of x is an element of all real numbers, but h of x cannot equal negative 7. Oh, and x, this one over here, I made a mistake up here in my tablature. Oh, and I lost my pen tool again. Oh, here it is here. Such an x, and there just needs to be an x right here. Okay, so I hope you found this video to be helpful.